Good afternoon, folks, and welcome to this, the fourth in a series of webinars on identity by Condatis. This webinar should last for around 30 to 40 minutes and will be followed by a Q&A session. My name is David Manning, I'm an architect, and today I'm joined again by Dave Downs, one of the senior developers here at Condatis. For those who've missed them, we have recordings of the earlier webinars in our B2C series on our website. These have been covering the basics of B2C, an introduction to development and deployment of custom policies, and the ability to federate with external identity providers and support single sign-on across services. Today, we're going to investigate different ways to integrate with external systems from within B2C policies, either for retrieval of additional data, or for persisting of additional user data, or generation and storage of telemetry and audit records for system monitoring and subsequent user support. We're also going to discuss a couple of possible approaches to user migration for service providers wishing to move to use B2C as their identity management solution. So Dave will lead us through some code snippets to illustrate the process of calling an API to retrieve data as part of the registration process, and then to store some captured data into an external source of user details such as a CRM. As part of these processes, we'll also show recording telemetry events using App Insights. We could also potentially record explicit audit events into a different audit store for subsequent user support. And finally, we'll give a brief overview of some of the options for user migration, which may also use APIs where the legacy system supports it. So there are a number of reasons for communicating with external systems as part of a B2C journey. You might want to generate a one-time passcode to an email address as part of the initial registration. You might want to generate a welcome email on completion of that registration process. As I mentioned, you might want to retrieve customer data, particularly any kind of service-specific access rights as part of an authentication journey. And you might want to store any new or changed customer details in a CRM or other user store for subsequent customer support. And it's useful to log the outcomes of all requested operations for system monitoring and subsequent customer support. In each of these cases, it's necessary for B2C to be able to communicate in a secure and timely fashion with the external source to ensure the success of the requested transaction while still protecting against unauthorized activities. And for CRM integration, it might be beneficial to implement a caching layer to improve performance, or possibly an asynchronous pattern to protect against different levels of availability within systems. There are different levels of protection that can be implemented when communicating with external systems to ensure that the sensitive data is kept private. And Dave will touch on some of these. So Dave's now going to take us through a demo of some instances of B2C using APIs to read from and to write to data in external systems. Dave.
Cool. Right, so let's flip to what is hopefully a now familiar site to anyone who's come to the previous webinars. So we've got our aligned party on the left-hand side, which we're going to sign into using B2C. And then over on the right-hand side, we've got our custom policies that define the journey the user is going to go through in B2C when we sign in. Now, anyone who came to the previous webinar, end of last month, they'll remember that we added a bunch of federation, social sign-in, that kind of stuff. We've removed all that for this webinar, so we can just focus on the API calls. But we've kept this sub-journey that defines our actual basic sign-in logic. So when I click sign-in, B2C is going to run through these orchestration steps, which we'll detail as we kind of go through the webinar. But these orchestration steps in particular, this local sign-in sub-journey, is what defines our step one, our user login page. If we sign in, great, we don't do a registration, we go straight to step 3, read them from the directory. If we don't sign in, if we do sign up now, we go to the registration page, which is step 2, and then we read them from the directory. So the same 3 basic steps that we've done in all the previous webinars, we're just going to enrich that now with some external API calls and some logging. So to that end, we've set up 2 external systems. One is some Azure table storage, which we're just using to store a row that relates to a user and then a comma-separated list of groups for that user. So when we sign in as that user, we want these groups to be returned in their token as roles that user has. We've also set up an SQL server into which we want to write users as they sign into or as they register with the system. And you'll see at the moment there's no one in there. Now, B2C can't interact with those external systems directly. We've got to write, or to already have, APIs that sit in front of them that B2C can communicate with. So if I flip to Visual Studio and just show you a bit of code quickly, we've written some APIs just using, plain ASP.NET Core. One that creates a GET request, so an API that accepts a GET with a particular user ID. It interacts with the table storage to read the user record and then split the groups they have and then return a JSON response with an ID and a list of groups. And I can show that very quickly working. So just an API client, we've got a URL, we've got a groups endpoint, accepts an ID, I send the request, and then we get back that JSON response with an ID and our two groups, our admin and our user, which are just our groups from table storage. Similarly, we want to write out users to that SQL server. So we've set up an API endpoint that accepts a post request and then just uses Dapper and an SQL connection to query whether the user is already in the database. If they are, we just update them a bit. If they're not, then we create them. So we've written our own APIs to interact with those two services, and now we just need to hook B2C up to those two APIs. Now, we're using fairly straightforward services here and fairly straightforward API calls to demonstrate. In practice, this might be hooked up to something like Dynamics or Salesforce or whatever external system it is. The logic for that can all live in the API, and then B2C will just communicate with the API. So if we go to our sign-in journey, let's take a look at what we're actually doing. So we want the user to either sign in or register first. And then once they've signed in or registered, we've got their ID, we've got the forename, the surname, all the different details. So we've got enough information there to both read them from the storage account using their ID and write their details to the SQL server. So after we've executed the actual sign-in steps, we've got another two steps, step 3 and step 4, which use an API to get the user groups and use an API to write the user to SQL. And if you remember from all of the previous webinars, all these orchestration steps are executing this technical profile that we've defined. So we've defined technical profiles named API get user groups and named API write user that do the actions that we want them to do. So let's go take a look at those. We've put those in our extensions-based policy. Remember, we're going to have a hierarchy of policy files, so we can split things up according to where they're going to be used and where makes sense for developers to find them. In this case, we might want to use these APIs across multiple different journeys, not just sign-in. So we've put them up in extensions, so they're available everywhere. We've defined our technical profile called API get user groups, and we've said to B2C that it's a RESTful provider. So B2C knows when it executes this technical profile, it's making an API call. Because it's an API call, it's got to have a URL. We've templated this URL. So when we use our tools to deploy this policy file, we'll replace that using a list of variables to be a particular URL. That's not a feature of B2C, that's part of our tooling. That might just be a hard-coded URL in the actual end policy file. We're saying it's going to go to the groups endpoint, and this is a feature of B2C. We're saying that this URL is going to have a component in it that's an ID, and that's going to be filled in by B2C by virtue of the fact that we're saying we want to send the claims in the URL. So B2C knows when it executes this RESTful API call, it's got a URL. We want to send any claims as part of the URL, so it looks at the claims we're sending in. We've got this object ID, the user's ID from the directory, and we're saying that we want to send that as the ID. So it takes the fact that we've got this input claim that we're saying maps to ID, and then when it executes the API call, it replaces that variable in the URL, so we can parameterize things that way. Because we're saying we want to send the claims in the URL, B2C knows that this is going to be a GET request, so we don't need to explicitly specify that anywhere. So it's going to make a GET request to that URL, replacing the ID with the object ID of the user. And then the very last component of this is we're saying we're going to authenticate this API call with a bearer token. And we're saying to B2C that bearer token is going to be stored in a claim that B2C knows about called bearer token. Now, you don't need to worry about where that's coming from at the moment. We'll go into that later. Just know for now that we have a JWT that we're going to use as the bearer token. We've stored it in this claim, so we're just telling B2C to use it, and we're passing it in so that it can use it. There's different kinds of authentication that we can use. We don't have to use bearer tokens. We could use basic authentication, so username and password, certificates, and B2C now supports API keys as well. So there's different options, but we're using a bearer token here. So it's going to execute its API call, make GET request to groups with the user's ID, and then we're saying we're expecting that API call to return a JSON response. We're expecting it to return a groups property, which we saw in our call when we made it earlier. So if I minimize this a little bit, so we're saying it's going to come back in groups, and it comes back in groups here, our list of roles, and we're saying to B2C, just store that in the roles claim. So then B2C stored it in that claim, and it's available for us when we're creating the token later on. Right user similar, we're saying again, RESTful provider, B2C, it's an API call. We're giving it a URL. In this case, it's our user's endpoint. Again, we're securing it with the same bearer token from the previous call. And this time we're saying we want to send the claims in the body rather than the URL. Because we're saying send them in the body, B2C knows this is a post request, and it knows that it's got to create a JSON object that it sends up as part of the request body. So all we do with the input claims is we tell it what goes into making that JSON object. So it should have an ID on it, it should have a forename on it, it should have a surname on it, and those are coming from the user's ID, their given name and surname, which are the claims that B2C knows about. So we're mapping from what B2C knows about to what our API knows about, and then vice versa when we have any output claims coming back. For our write, we don't have any output claims coming out. We could do. It doesn't have to be just a one-directional write. We could, for example, have an ID being returned that relates to the external system that we then store in B2C. So any future writes, we use that ID to do the write. But for this, we don't have anything. So we're expecting our user to do step 2, sign in. We want to get the user groups, so they should then form part of the token, and then we're going to write our user. So let's sign in. So this is just using the same user that we've used for all of the previous demos. When it signs in, we'll get back our hopefully now familiar token with all of our claims that we've had so far. So the ID of the user, the policy that we're using to sign in, their email address, all of their name details. We know this user is authenticating using a local account, and we'll talk a bit more about this later, but this is just a claim to say how we authenticate the user. And then we can see here we've got our 2 roles, our admin and our user, that we're getting from our storage account. So admin and user here. If I change our storage account, so let's add test role, update that. So if I make our call with our API, so where we only had user and admin, if I now redo that, we now get user, admin, and test role because we're hooked up directly to the storage account, and we can see from B2C if I just sign in again. Exactly the same details. We're now getting back 3 roles, our admin, our user, and our test role, to reflect what we just updated in the storage account, because all B2C is doing is making API calls to our API, which is then communicating with the storage account. So similarly with our write user, B2C is part of our sign-in. If I bring up the policies again, we'll have made our write user call. So in our SQL server, where before we didn't have anything, now we've got our user with an ID that should match our object ID, and then our forename and our surname, and just the date the user was created. If I move that over there, so our ID for our user, ignoring case, is exactly the same. So we've just written our user's ID to SQL. So that's shown us doing 2 API calls as part of our main journey. Now, we talked about having that bearer token that we said was stored in a claim. We're getting that because we're executing an API call that generates that token. So you can see here, step one of our journey, before we've even done the sign-in, is this get token step. And all we're doing is executing another technical profile called API get token, just like we're doing API get user group and API write user. So if we go have a look at our APIs, so you'll see here, again, same as the other ones, it's just another RESTful provider with a URL, different authentication type, but we're still sending the claims. I mean, this time we're doing them in a form, but what we're doing here is we're making an OpenID Connect request to our B2C's Active Directory, and we're saying use the client credentials grant type, giving it a client ID and secret of an app that we've registered in Active Directory that represents B2C, and we're saying generate a token for that app. And then we've set our APIs up, our .NET Core APIs, to expect that token and then authenticate it against that Active Directory. This needs a bit of knowledge about how OpenID Connect works, but using bearer tokens and OpenID Connect in this way is a fairly standard way of authenticating APIs. And it's one of the more complicated ways that you're going to set up, but just to show that B2C does support that, you can generate a bearer token at runtime while the user's executing this. It returns an access token, which then goes in our bearer token claim, and that's the one that we're then using kind of as we go along. So we can generate these tokens, not just from AAD, whatever we're using to secure our APIs, anything that's compatible with OpenID Connect. We could make an OpenID Connect request too, get a JWT, use that to secure them, or we could use other things like basic authentication or client credentials, client certificates or API keys. So with that being basic API calls, reads and writes as part of your journey, there's another way that you might want to use an API call as part of B2C, and that's to expand the validation. So from our registration flow, we've got a fairly basic registration process here. We're allowing the user to enter a password, and we're capturing some basic details about that user. Now, B2C out of the box provides us with some good default rules for testing password complexity. We can make sure that it must have mixed case, uppercase and lowercase. It must have numbers, special characters, certain numbers of each. It must be a certain length, that kind of thing. But what we want to do is we want to add in some additional rules to run our new passwords through a password validation library to see whether it's easily guessable or whether it's a common password, and also to run it through an external service like Have I Been Pwned to see whether that password has appeared in any breaches. If it has, then we don't want to allow the user to use that password. So if I get my email address ready, so let's set up a new user account. So all we've done for this is we've set up some new API calls. We've set up two new API calls, which we'll show you in a minute. One's going to be used by the client side. So it's going to be used by this page to validate the password as the user's typing it. And that works in exactly the way you'd expect. There's JavaScript on the page, it's looking for changes, it's making an AJAX request and then showing the error actually on the page. The other API call will be called by B2C on the server side to make sure that the user hasn't bypassed the client validation here. So if they enter a password quickly, which we'll do shortly, or if they've somehow disabled the client side validation, when they submit this form, we'll still check it on the server side. So what does those APIs look like? So again, we've just set up some .NET Core APIs. We've set up two API calls here, one that's going to be called by B2C. So this is again secured with that same bearer token, which is our validate call. And then we've got another one that's public that allows anonymous calls. Our public one just loops through all the password validators we've got, which we've just got two of them. We've got our ZXCVBN password validator, which just runs it through a password validation library, and our pwned password validator, which sends it off to, or sends a hashed part of it off to Have I Been Pwned, checks whether it's been in any breaches, and if it has, we display any errors. So if there's any validation errors, The public one returns an OK response along with those errors. If there aren't any errors, then we just return the OK response with everything's good. The server-side one, we run through all the validators, so same logic again, but this time if there's errors, we return a bad request rather than OK. And that's because B2C needs the response returning in a particular format. So we say, because this is B2C server-side validation API, if it fails, we return a bad result, and then that result in a particular format, so B2C can look at it and goes, okay, the validation's failed, the user message that I should display to the user is X, and then the message that I should log that might be for the user is Y, and we've got these different levels of information. And you'll see here that we're also catching all exceptions and then throwing a B2C exception, because we've got logic that again handles any request that B2C are making and make sure that the responses are formatted correctly. Because the public one's an AJAX call, we can handle that in a much more generic way using JavaScript. But with the B2C ones, we need to be a bit more specific about how it handles errors. So if I show this working, and then we'll look at what the policies do. So if I enter password as my password, you'll see we still get the B2C password logic running, saying it must have certain numbers of characters, it must be a certain length, but we're also getting errors that our password can be easily guessed, it's one of the top 10 common passwords, add some words. So we're getting recommendations as well as failures, and that's coming from our password validation library through that API call. If I had a capital P, it's still a top 10 common password, and we start to get capitalization, doesn't help much. If I make it so it's not a top 10 common password, so it now passes the validation, but we know it's been in a breach, because this is have I been pwned returning to us, this password has been in a breach, you shouldn't use it. If I enter one that's valid and fill everything else in, so this, so that looks good. If I now try and beat the client-side validation, so there I've submitted the form faster than the client-side validation run, so everything got submitted to the server, but you'll see up here the errors appeared up here as well as here, and that's because B2C server-side errors by default will appear at the top. So this is just, we've submitted the form to B2C, B2C's run the same API call, or the version of the API call that it runs on the server side, and we've got back the same error from the server as we get on the client side. So bearing in mind this is just AJAX, so this works exactly as any web developer expects. What does the server side one look like? Well, if you remember when we were going through sign up, all of the pages are just themselves technical profiles that we execute. So we've got a technical profile set up called user account sign up that details what this page is going to look like. So we're capturing the email that gets verified, so we do the one-time passcode. We're capturing the password, which gets re-entered, given name, surname, etc. And then we're getting object ID and display name out, and authentication source and other things because we're saving the user. Now, we've got these validation technical profiles, which are the validation rules we want B2C run when this page gets submitted. In previous versions of the webinar, we only had one validation technical profile, which was this AAD create user by their email address. So we were saying, provided all of the claims are filled in, and they all look correct from the password validation, we just want to create the user in Active Directory using their email address that they've entered. What we're saying now is we've got an additional validation rule, and that's this API validate password technical profile. So we run that through first. If the validation passes, great, we go on to the next validation rule, and at that point we're creating the user in the directory exactly the same as we were before. If this rule fails, so if we return that bad response from the API, then B2C knows, okay, the first validation rule's failed, I won't run any more, I'll just return that error to the user. So our API is returning this, B2C picks that up as part of its bad response, and then just displays it as part of this form having failed its validation. So what does that validation password API looks like? Well, as you've probably guessed, it looks much like our other API calls. We've just set up another technical profile with that name. It's a RESTful provider again, it's got a URL again, bearer token used to authenticate with that same claim. So because we're We've written all of these APIs and we're hosting them all in the same place. We've chosen to authenticate them all using the same token. We're sending the claims in the body, so it's just another JSON, it's another post, and we're just posting up the password. We don't have any output claims, so we're not reading this error as part of the output claims. Because we're returning this bad request with the error in a particular format, B2C understands that and will automatically pass it up. So we don't need to do any manual parsing ourselves here. B2C picks it up by convention. It knows how to read that response and how to filter that through into user messages here and also logging in the backend in App Insights. So all of that comes together, our validation here, our technical profiles, whether we return a good response or a bad response, and then ultimately we get a new user or we get our validation error. So if I just register this user, submit that with a valid password, and just like all the other webinars, it goes through and we've got our newly registered user, Dave.demo. We've got a role from our API, so that's coming from our storage account. We don't have a storage account record for this user, so if I flip back to storage and just refresh over here, we don't have a storage record for that user, but because our API logic said if we don't just return user, our API returns user, so B2C gets that user rollback. And then similarly, in our SQL server, if I refresh over here, our write still ran, so we still got our row in our SQL server. So all of our other API calls are running because we've set them up in our policy file, in our journey, to run regardless of whether it's a new user or not. So that's the basics of how we're going to use API calls. We've got our reads and our writes as part of the journey. We're using them for validation. The next thing we probably want to show as part of the demo is custom auditing messages. Now, B2C does have its own built-in auditing. It will log certain events and store them inside B2C for a period. You can set up Azure Monitor to pull them out of B2C and then move them to wherever you want them to go. Use the Azure infrastructure to store them or transfer them around into whatever system you've currently got set up. We're not going to really touch on that as part of this webinar. Instead, what we're going to talk about is more custom events that you want to log as part of your journey when certain events happen, maybe that wouldn't be recorded by B2C. So to show that, we've got these two orchestration steps as the very last thing we do. So once we've been through the rest of our journey, once we've signed in or registered, got our groups, written our user, we want to do one of two things. If we're not a new user, then we want to execute the app sign-in success technical profile. So we want to log to App Insights that a sign-in has happened successfully. If we are a new user, then we want to log that a registration has happened successfully, again using App Insights. And this new user claim that we're making this decision on is coming from the fact that if we did a registration successfully, we've set this new user to true. So if we did a sign-in, it won't be true. So again, these are just technical profiles, the same as the API ones were. So what are those doing? So if we go over to here, we can see our App Insights registration success. So we've set this up with input claims, and we've said include another technical profile. So we pull everything that this technical profile is doing in to the definition for this one, and then only override the bits that we need to. So we're saying use App Insights common, and then also supply an event type of registration success. So our App Insights common, if we go look at that, because App Insights could be used anywhere, is in extensions. We've said it's an Azure App Insights provider. So this is just a way of saying to B2C, communicate with App Insights directly. Again, we're using our tooling to provide an instrumentation key to different environments. So in an actual policy file, when it's deployed, this will just be the GUID key, same as it would be for accessing App Insights using anything else. And then we're just saying what we want to log as part of this. So timestamp, client ID, so the unique ID of our app that's signing in, policy ID, so the name of the policy that it's using, correlation ID. So if we're logging multiple audit events, then they'll all get the same correlation ID, so we can map all the things a user did while they were executing a particular journey. Different users will get different correlation IDs, different sign-ins by the same user will get different correlations IDs, so we can just map for a particular journey what happened. culture, so the culture the user used, and then their user ID. So all of those things will be logged to App Insights, along with the event type of registration success for registration success. And then for the sign-in, exactly the same, App Insights sign-in success. We're doing App Insights common again to get all the common properties plus sign-in success. So from our sign-ins and our registrations that we've done, if we go look at App Insights and we go look at our custom events, hopefully if I filter this down to the last hour and refresh, we might see my events from earlier. So we see all the events that we've been doing over the last hour. And if we view more insights, so we deselect the ones that we don't care about, browser version, country and operating system, and we select the properties that we do care about. So our client ID, which are app, our journey, our policy rather, and our user ID. So we start to get an idea of the users that are signing in, the users that are registering. So we're always using the same app. We're always using the same policy. So anyone who came to, I think it was the second webinar that we did, will remember that we had another app that we could sign into our SAML one, which used a different policy. If we'd used that, we'd have a different client ID, a different policy name. Those are the kind of things that start to build up a picture of who's using what. Our user IDs that we're tracking to say how many times has a user signed in or registered, and the events that are happening. So we can see here all of the events that we've just been going through, plus mine from when I've been running through it earlier. We can see our registration success is happening and our sign-in success is happening. These are all logged as events, so this is just App Insights giving us its view of them, but you could use log analytics to look at them. And then again, because they're all in log analytics, you can use standard Azure architecture to pull them out and move them around and do whatever. Anyone who's kind of building up a picture of how this all works will probably have had the thought, well, these are just technical profiles that we're executing, so can we replace them with API calls, because these are just technical profiles that we're executing? And yes, we absolutely could. So these don't have to be App Insights. We could have API calls that we write certain event information to, and then the API call forwards that on to wherever it needs to go, which could be App Insights, it could be SQL, Cosmos DB, Event Hub, you know, wherever it wants to be, a multitude of things, and you're just using your API to maybe aggregate them at that point. That's all absolutely doable. All we're doing is executing technical profiles. That's quite a lot of information there. So if you've got any questions, feel free to stick them in the chat or to get in touch with us afterwards. But for now, I think time to move on to migration.
Brilliant, thanks, Dave. It's a fairly comprehensive view of what's involved in interacting with external systems using APIs. So yeah, now we're going to turn our attention to user migration as part of onboarding existing services to B2C. The first thing that's needed is a migration strategy. We need to identify what data is needed, what needs to be held about the user, where those attributes are stored, whether it's going to be in B2C or in a CRM or some other customer data store. So as a rule of thumb, login-based identity data should go into B2C, but anything else, any sensitive data, should go into a dedicated customer data store. So anything related to marketing campaigns, account information, anything that's not really needed for login should really go into a separate store. And there are a number of different options for migration. The optimal one, I'll call it the optimal one, the best one really, is to be able to perform a just-in-time migration using B2C to capture the user's credentials and then having B2C use an API to issue an authentication request to the legacy system. If that's supported, it's great because it allows the existing credential to be verified. And then since B2C captured the credentials, it means that B2C can verify, for example, that the password meets the password strength constraints, or as David showed, it hasn't been, it's not one of the top 10 most used, hasn't been compromised. And then it allows it to be stored in the Active Directory for subsequent locally managed authentication. So if the password doesn't need to be reset because it passes the checks, it provides a seamless migration of the user. They use the same username password, they get authenticated remotely initially, their details get transferred across and held in B2C's AD, and all subsequent authentications will then be done locally and the user doesn't really know. If the legacy system doesn't have an authentication API that allows that, but we do know the password hashing algorithm of the remote store, it may be possible to write a wrapper API that could perform the password hashing and then do a comparison against the legacy credential store. So it's similar, but what it means is we'd be taking on the responsibility of doing the password hashing to do that comparison rather than delegating to the remote system to be able to do the authentication for us. But we still get the benefit, assuming that it succeeds, of being able to store the user's credential information in Active Directory and the user's none the wiser. We get that just-in-time migration. If the legacy system doesn't have those facilities, if it can't do remote authentication or we don't have the facility to do the hashing, an alternative is to use a password reset process. So you direct the user to a reset password process. Normally you do an identity verification challenge, which might be something as simple as a one-time passcode being sent to their verified email address or perhaps a mobile phone for using a different channel, or a knowledge-based challenge making use of some data that's held in that external source. So if it's slightly more sensitive, you might be able to put together a knowledge-based question and verify the answer against the external source before we transfer the user details. And at the end of that, request that the user sets a new password, and that way B2C then gets the password to store for subsequent use. One possible optimization is to be able to transfer basic user details of all the users that the service provider wants to continue to support into B2C's AD in preparation for migration. What this does is gives the service provider an opportunity to perform some data cleansing, to identify and remove any duplicates, and to choose not to migrate any obsolete accounts. So minimizing the amount of data that's coming across and targeting the users that are going to be migrated. The drawback of that is that the data that's transferred is going to be based on a point-in-time extract from the legacy system. So we need to be careful that any changes to the master data are prevented, or we have to implement a synchronization process to ensure that the seed data is kept up to date. The seed data that's put into B2C is kept up to date. And B2C needs some method to be able to determine which of the bulk loaded accounts have already been migrated and so can be authenticated locally, and which are still pending and therefore require the migration step to complete the transfer. So a couple of options there. Let's have a look at a just-in-time migration in action.
Okay, so we're going to use the same principles that we've just used for validating the registration and doing the sign-in to try and do a migration of a legacy user from an external system into B2C. So we've got over here an ASP.NET users identity table. So this is a table that might be used if you had a site written in ASP.NET or ASP.NET Core using kind of the built-in identity logic as part of that. It stores an ID, a username, which is their email address, a hashed password, and then there are things like the forename and their surname, along with some other information. We've written an API to interact with that. So same as we had for validating the passwords, we've got this legacy users API, which uses the ASP.NET identity logic to find the user by an email address that we provide, do some checks to make sure that the user exists. We verify that the password they're trying to use that's been passed to this API matches the hashed password in the identity store, again just using the built-in ASP.NET identity logic. And then we get a verification result back to say either it failed, so the password is invalid, or it's okay, and then we return all of the details, that our legacy system knows about the user. So our ID, email address, forename and surname, because we're going to use those in B2C. So B2C is going to call this API, which interacts with our legacy system, which in our case is an SQL table, but could be whatever it needs to be. So our policies, again, largely similar. We're just doing validation. So if I do a sign in over here, so what we want it to happen this time is when we try and do a sign in with our legacy user details, it seamlessly does the sign in for the user, making that API call. We don't want them to click any additional buttons to say, I was a user on the previous system, I want to come across. We don't want the user to know that a change has even happened. So we've got our user on SQL, just to show there's no smoke and mirrors. In our B2C user store, we've only got our users that already exist, so our demo that already exists, our demo that we registered, and then my regular admin account. We don't have our account we're going to migrate, our legacy user one account. So our page here is our sign-in page. So if we go find that, user account sign in here. So again, just another technical profile that we've set up as a page in B2C, capturing the email address and password, and then returning a bunch of information. Before, same with the registration, we just had a single validation profile, which was check against the directory with the email and password to see whether the user was on there and whether the password matches the email address that we've got. We've changed this slightly. We've added additional validation rules, but we've also changed how we respond to this validation failing. So what we're saying with this validation rule now is we still check the directory first. We still do the same check we did before. But this time, if the check's successful, so if the user is in the directory and their password does match, we don't want to continue with any other validation rules. So we don't check the legacy system. We don't do anything else. We just carry on from this page with whatever steps next. So all of the get groups and write user. If the validation check fails, we do want to continue running the other validation rules. So we're essentially doing things here in a way that's inverse to what we were doing on the registration. There we weren't continuing if there was an error and only continuing to run rules if it passed. Now, if it passes, we don't want to run any other validation rules. We want to just continue on, done. If it fails, then we do want to run additional validation rules. So what's the next step? If we're not on the directory, then we want to make this API call to authenticate the legacy user. Well, that, just the same as all the other ones, is just another RESTful provider. It's got another URL. Again, we're using the same bearer token because we've written the API. We're hosting it in the same place. We're sending the claims in the body, so we're doing a post with the email address and the password. And then we're expecting to get back from the API call details about the user. And we're setting the authentication source here to be a migrated account. So if we run this authenticate legacy user and it passes, then our authentication source is we've migrated that user account. We're not really doing anything with this other than showing it kind of at the end of the process, just to show the users that have been migrated and the users that haven't, but it's just to show that we are setting this for migrated users. So we run the API call. If we migrate them, or if we authenticate a migrated user successfully against their legacy system, we carry on running validation rules. So the next step is to do a creation of the user on the directory by their email address, exactly the same as we were during a registration. So by signing in as a legacy user and being authenticated against the legacy system, we're essentially silently behind the scenes treating that as a kind of registration. So the user gets registered in B2C without actually knowing that they've been created in the directory. If this failed, then we just display whatever error it is to the user. So if I type in, and I get the password wrong, so I try and sign in, I get an error message if I enter the password wrong. And this is a message that we've set in our API layer, so we're in complete control over what this message is, and we're just highlighting here that I've typed the password in wrong. In practice, that probably wouldn't be the error message, but it's just to show that we can get errors back from this API and they get displayed as part of the validation. I log in with my actual password. So again, we go through the whole process, all of the API calls. So we get a user role from our storage, even though we don't have a record in storage, because it's a kind of registration. Our authentication source is migrated account, because we know it's one of these legacy users that we're migrating. But otherwise, our token is exactly the same as for a regularly signed in user. And if I take a look at our table over here where we only had our 2 users, we've now got our new user as well. So again, we're running through all of those API calls. If I sign in with that user again, so user 1, sign in, and then we get the same token again, but this time we can see authentication source is now local account, because we've done that step of writing the user to the directory as part of checking that they're a legacy user, and because they're in the directory, any future authentications pass at that step. We've migrated them into B2C, and we can go look at our list of B2C users and see if we refresh that, we've now got our legacy user 1 in there as well. So we've migrated the user from the old system. We can at some point sunset that old system if we've got all the users that we needed out of it. And that's a basic migration.
Great. Thanks for that, Dave. So that's an overview of using B2C to communicate with external systems via APIs for retrieval, for storage of data, for additional verification, for audit, for telemetry, for migration. We've covered some of the security measures that can be applied to APIs to prevent unauthorized access. And we've mentioned possible use of caching to mitigate against system unavailability and slow response times. And just there, we covered some of the options on migration and the possibility of using APIs there to migrate users of existing systems when they're being onboarded to B2C. So Dave, do you want to cover what we've talked about here?
Yep, anyone who's been to the previous webinars will probably be fairly familiar with this diagram by now. So we've basically shown at this point through the webinars the various common building blocks that we use as part of building up custom policies for B2C authentications. You can see here that we've highlighted the REST API component because that's the one that we've been focusing on here. We've also highlighted the fact that we can interact with the user directory using Microsoft Graph API because we talked about migrating users in bulk from a legacy system into B2C. And chances are that'd be some standalone app that would use Graph API to migrate everyone across. But in the past, we've talked about using local accounts and federation, how we do MFA using phone SMS. We saw email address verification there using one-time passcodes, and then all of the user input using the technical profiles and interaction with the user directory and how the token gets changed based on what we're returning from the journeys.
And as we said before, Microsoft continue to develop B2C product. And so in the next couple of webinars, we're going to investigate some of the more recent and more complex scenarios that can be achieved. Okay, that's it. So Q&As, let's have a look, see what questions have been sent in. There's been a few questions actually. The first one, can B2C call an unsecured API? So you covered bearer tokens and you also mentioned different options for securing the APIs, but can you call an unsecured one?
Yes, there are some caveats with that. So if I flip back to here, so if I find one of my API calls in here, so you'll see that, like I called out, where we've got the authentication type, we mentioned that it's bearer, we mentioned that it's bearer token. We've also got another item that we didn't really touch on called allow insecure auth in production. So B2C would prefer if you always used an authenticated API. If you do want to use an unsecured API in production, so you want to allow anonymous calls to an API, then it now requires you to add this item to the metadata and set it to true to say, I understand that this API call isn't going to be authenticated in a production system, and then B2C will execute it. Otherwise, if that flag's not there or it's set to false, when you deploy your policies in production mode, then B2C won't allow you to call that API call. So yes, it will, but it requires you to be explicit that that's something you were intending to do.
Okay. So it's trying to protect you, and you have to be very explicit about wanting to do it, which would presumably be because you're accessing data that's in the public domain, and so there's no concerns around. Okay, what else? Can B2C integrate with APIs that already exist rather than having to write them explicitly?
Yes. So if you've got an API that's just returning some information using JSON, then chances are B2C is just going to be able to integrate with that, and you're probably not going to have much of a problem. You might have to do some work around the authentication because, like I said, B2C only supports certain authentication modes. So as long as your API also supports that, or is a public one, then B2C is probably going to interact with that fine. You can say execute the API and then have the JSON response parts, the properties, populate claims. Where it starts to get a bit more complicated and there's less chance that you'll just be able to integrate with the API is when you're doing things like validation. So I touched a bit on the fact that B2C expects the response in a certain format and expects the status code that comes back from the request to be in a certain range. It expects a 400 range, so a bad request. If your API doesn't do that, if it only ever returns 200s, then you might be able to jump through some hoops to make it happen, but it might just be best at that point to write a wrapper API. So B2C calls the wrapper API, and then the wrapper API calls your original API. So you're writing an API that B2C can talk to in the format that it wants, and then that communicates with your actual, end product, which is what we do for things like Dynamics, where Dynamics has an API that you can interact with, but it's maybe not set up in a way that's easy for B2C to communicate with. So maybe we'll set up an API on top of that that does caching, does asynchronous calls, all that good stuff, but primarily converts the way that B2C likes to talk to APIs into the way that the Dynamics API talks, or Salesforce, or whatever. Okay.
But in principle, the idea of wrapper API is quite handy then, because it means you can make use of whatever's out there, but you can tailor it to work in a way that B2C needs, and also gives you that additional control. So by having a wrapper, it allows you to do things like asynchronous calls, retries, whatever.
Yeah, and if you do have an API that's just it's literally, say, a get that returns some information in a fairly standard format, and it supports an API key, chances are you can probably just hook that up to B2C. You might not need all the extra stuff on top.
Okay, all right. And does it matter where the API resides? Could we call an API? Sorry, could we call APIs that are running on AWS?
Yeah, it's standard, HTTP, HTTPS requests. It is a REST API request in the true sense of the word. So it doesn't matter where it's hosted, as long as it's accessible to B2C. So it's not on a private network. Say it is accessible to the internet, then B2C is going to be able to communicate with it.
Okay. Is there a limit to the number of APIs that can be called in a user journey?
No more so than there's any other limits on the user journeys. So we saw where we were executing like the get groups and the write user. Those are just orchestration steps that we've added to the journey. You can have more than that. They can be in different orders. You can do it however you want there. You're just adding unique technical profiles that you're then saying execute in this journey at this particular step. There's not like slots or anything that you're taking up by having API calls.
Okay. And the final one we've got: if you were migrating from multiple legacy systems, each with their own authentication system, into a single B2C tenant, how would you go about this? It's quite complicated.
So just say that again.
If you were migrating from multiple legacy systems, each with their own authentication system, into a single B2C tenant, how would you go about it?
So it depends on what those authentication systems are and how easy it is to identify that a user should be using one of them.
Yeah.
So you could combine everything that we've talked about up until now. Well, chances are you would combine everything we've talked about up until now in all the previous webinars into the solution. So maybe you've got an API that can identify which system the user should be using, and then have B2C use that information to redirect them down a particular federated route. So if you've got, say, 4 different legacy systems, each of which support OpenID Connect, or some support OpenID Connect, some support SAML, you'd set all of those connections up in your custom policies and then have some logic to route the user in the correct way. If it's just multiple API calls, so you've got these 4 different systems, each of which has a different database, but you just want to make API calls behind the scene to migrate the user like we were doing just on our system now, then it's just about figuring out what you want that logic to be. Do you want to make API calls in sequence to call each one of them and try the user against each one? Is there some way of identifying that the user should make a request to a particular one, and then setting up the B2C custom policy logic to either validate against the correct one or to run through an orchestration step for the correct one, or to make all of that part of a single API that has all of that logic in it, and then B2C just calls that one API. So there's basically as many different ways as you can imagine of doing this, depending on what exactly these legacy systems are, whether they're things that you can federate to, whether there's information about which user belongs to which one, or which type of user belongs to which one, and what you can do with the API calls. That's the kind of thing where I'd say, get in touch with us. We can help design that process. We can, come up with all the pitfalls and what that should look like in terms of B2C, and start help planning out the policies and what implementation would actually look like.
Yeah, absolutely. I think what it highlights is there is no one size fits all, and it's important to have that strategy that says understand where your users are, understand any logic for getting them across.
Yeah.
Excellent. That's it. That's all the questions we've got. So thanks everyone for attending. I hope that you found this session useful and that you'll join us for the next few webinars in the series. If there's any specific B2C related topics you want us to cover in future sessions, please do get in touch. As I mentioned earlier, in the next session, we're going to be covering alternative options for strong authentication, some extended customization, such as customized emails for multi-factor authentication or registration invitations, registration confirmations, and we'll cover some recent developments in conditional access, which gives greater control over user journeys. As a reminder, we also have our SSI webinar series, which introduces and builds on concepts of decentralized and self-sovereign identity. The initial broadcasts of those are available on our website if you didn't manage to catch them at the time. The next session in that series is next Wednesday, the 20th. So please make sure you sign up for that if you want to understand some of the advantages that can be gained from using verifiable credentials. And as always, if you want to discuss any aspect of identity and access management, or if you're interested in using Azure AD B2C for your identity and access management system, please do get in touch with us using the details shown. Thanks again.